Data is the invisible architecture running the modern world, a relentless flow that scales and reorganizes by the millisecond. Selecting an incompatible SQL database for this infrastructure leads to crippling licensing costs or system crashes once workloads reach a certain threshold. This choice is rarely a competition of raw software quality. Success requires balancing three specific variables: the available budget, the complexity of the data, and the existing technology stack. A database serves as the operational identity of the entire organization. To navigate these options, we are looking at the Comparative Guide from Royal Research, a firm specializing in enterprise data infrastructure analysis. This analysis focuses on the four leading SQL databases in the industry: MySQL, PostgreSQL, SQL Server, and Oracle. A primary strategic divide separates these four: open-source agility versus commercial enterprise power. The open-source side offers high flexibility and zero licensing costs, though it requires manual configuration to scale effectively. The commercial side provides out-of-the-box advanced security and extreme scale, but introduces steep licensing fees and vendor lock-in. Efficiency depends on locating the exact scenario match for your current operational constraints. Within the open-source arena, the baseline standard for speed and simplicity is MySQL. Under a free GNU license, MySQL delivers high-speed web transactions with maximum cost efficiency. However, MySQL lacks built-in tools for managing highly complex, unstructured data or intensive data science workloads. Developers requiring advanced complexity without commercial fees often turn to PostgreSQL. PostgreSQL natively handles custom data types, geospatial processing, and JSON, or JavaScript Object Notation, a format used for storing and transporting structured data. It uses ACID compliance to guarantee strict data integrity during complex transactions. ACID is an acronym for atomicity, consistency, isolation, and durability, the four properties that ensure database transactions are processed reliably. This analytical power requires a steeper learning curve and higher administrative effort to optimize compared to MySQL. Ultimately, staying open source forces a choice between the raw web speed of MySQL and the deep analytical rigor of PostgreSQL. In the commercial sector, larger budgets prioritize vendor support and ecosystem synergy. Microsoft's SQL Server provides a structured, comprehensive choice for enterprise environments. The primary benefit involves paying for a commercial license to unlock seamless integration with Microsoft tools like Azure and Excel. Built-in business intelligence tools save corporate teams significant time by automating data visualization and reporting. Adopting this system binds the organization to Microsoft through vendor lock-in and ongoing enterprise licensing fees. SQL Server trades high licensing dollars for immediate, frictionless productivity across an existing corporate ecosystem. Certain mission-critical environments, such as global banking, large-scale telecommunications, and government infrastructure, have absolutely zero tolerance for any system failure. For these budget-agnostic scenarios, Oracle Database remains the benchmark. Oracle prioritizes continuous high availability and immediate disaster recovery at a massive scale. It uses real application clusters, or RAC, which allows multiple servers to run the database simultaneously. If one server fails, the load reroutes instantly to the others, eliminating any single point of failure. This incurs the highest financial cost of any option and requires highly specialized, expensive database administrators to maintain. Oracle functions as a multi-million-dollar insurance policy against the catastrophic costs of enterprise downtime. The findings from the Royal Research Report provide an objective operational map to navigate these overlapping features. This flowchart links your technical reality directly to a business profile. If you are deeply invested in the Microsoft ecosystem, route directly to SQL Server. For a corporate IT director, the licensing cost is offset by hours saved through native Power BI integration. If the answer is no, consider the next node. Are you managing mission-critical infrastructure with an agnostic budget? If yes, route to Oracle. For the enterprise architect, zero downtime is worth the financial expenditure. If neither applies, you must choose between simple web transaction speed and complex data analytics. A bootstrapped developer prioritizing fast CMS deployment and transaction speed aligns with MySQL. CMS stands for Content Management System, an application used to manage web content. A data architect handling complex, specialized datasets while needing an open-source solution aligns with Postgres. This alignment prevents a company from overpaying for unnecessary features or failing under unpredicted scale. Database migration after an application is live is one of the most painful, risky endeavors in modern technology. Technical features must answer to the organization's current budget and specific technological landscape. Measure twice and cut once when selecting an operational engine. Select the SQL database built specifically for the road you are actually driving on.